Okay, this problem has a shape given above, that is the graph of f prime, and it says the function f is differentiable on the closed interval from -6 to 5, satisfies an initial condition here of f of -2 equals 7. The graph of f prime, which is the derivative, has a semicircle and 3 line segments. So that information is helping me to realize that we have a triangle and a semicircle and a triangle going on in our picture. Okay, so the first part asks us to find f of -6 and f of 5. f of -6 and f of 5. Okay, the initial condition we were given was f of -2. So in general, for part A, if we wish to find out what f of anything is, we will need to take f of -2, which is 7, and add to it the integral from -2 to whatever x we want of f prime of t dt. That's the way in general we figure out what the value of any part of the function is. So that's our general rule. Let me use a different color then to be able to figure out what is f of -6. So f of -6 would then become 7 plus the integral from -2 to -6 of f prime of t dt, which would be 7 minus an integral from -7 to -2 of f prime of t dt. And that's because when we switch the bounds, we take the opposite of the integral. So from -2 to -6 means now we've got to consult our table up here, or our graph rather, and from -6 to -2 means we're looking at the area of this triangle, which is above the x-axis. That triangle has a height of 2, and it has an x length or base of 4. 4 times 2 is 8. 8 divided by 2 is 4, so the area of that triangle is 4. So that means the final answer for f of -6 is going to be 3. We're definitely equal to 3. So in a different color, let's do f of 5. f of 5 would mean we would need to take 7 plus an integral from -2 to 5 of f prime of t dt. So of course that would be 7 plus, now for the -2 to 5 part, we would have to add on the semicircle, and then we would also have to add on the triangle. The semicircle, since it's a radius of 2, the area of a circle of radius 2, the area of a circle of radius 2 would be pi r squared, which would be 4 pi, but we're only talking about a semicircle, so that's only 2 pi, and it's below the x-axis, so this is actually going to add on a -2 pi worth of value. Plus, from 2 to 5, we now have this triangle. The area of a triangle is 1/2 base times height. So I have 1, 2, 3 for the base, 1, 2 for the height, and 3 times 2 is 6, and half of 6 is 3. So we're going to add on 3 for that triangle. So the answer to this problem at the end is going to be 7 plus 3 subtracted by that 2 pi. So we end up getting 10 minus 2 pi. Okay, good warm-up then, right? That's part A. What do they want in part B? B asks, on what intervals is f increasing? On what intervals is f increasing? So to figure out when f is increasing, we'll justify that with the derivative. So I'll make a number line here that represents the derivative. So according to the graph, which is f prime equals 0 at -2, and it also equals 0 at 2. Before -2, the derivative is positive. Between -2 and 2, it's negative on that semicircle, and over here it is positive. And remember, this is only considered on the interval from -6 to 5. So the intervals where we are increasing, we would say that f is increasing on the places where the derivative is positive. So that would be -6 to -2, and that would be unioned with the interval from 2 to 5. So that was a nicer one than the last one, right? A little bit less work. Okay, part C. Part C asks us to find the absolute minimum value of f on the entire closed interval from -6 to 5. So I'm going to use the part that I already did in B to acknowledge that the graph is going upward, then it's going downward, and then it's going upward. So as far as where the absolute minimum could even occur, right, it's either going to occur at this critical value right here, or it could possibly happen on this left endpoint right there. So in part C, we would say by the number line, the absolute min is either at x equals -6 or x equals 2. Those are the only two places it could possibly be. Now, at x equals -6, we remember that f of -6 from part A we already calculated. F of -6, remember, was equal to 3. That's equal to 3. So we really just have to figure out what's f of 2, right? F of 2 would be found by performing this. So f of 2 is equal to 7 plus the integral from -2 to 2 f prime of t dt, and that's 7 plus, we have to add on this semicircle. We already did that in part A. That's at 2 pi, but remember it's above or it's below the axis, so it'd actually be adding on a subtraction of 2 pi. So the answer to that value, f of 2, would be 7 minus 2 pi. Now this is not calculator active, so we actually have to do a little bit of analysis here. This is 3, right? F of -6 is 3, and 2 times pi is 6 point something, so 7 minus 6 point something means this number is really, really close to, or it's getting a little bit less than 1, right? Because we're subtracting more than 6 from 7. So we would say to this problem, to answer it, the absolute minimum value is 7 minus 2 pi, which occurs at, it doesn't actually ask for this, but just to make sure we're filling it in, this occurs at x equals 2. Okay, last part now. Now we're going to do part D. For part D, it says find f double prime of -5 and f double prime of 3, or explain why those values don't exist. So for part D, f double prime of -5 would be the derivative of the derivative at -5. And this was our derivative. So if we go to -5 is located right here. Notice that the function f prime is a line, and what is the slope of that line? See, it's rising 2 over 4, actually down 2 over 4. 2 over 4 is 1/2, so f double prime of -5 is -1/2, and that's according to the picture, right? The picture has the derivative of a line is just its slope. And then f double prime of 3, so if we come up to the picture again and look at 3, let's see, we have 0, 1, 2, 3. Uh-oh, we're at that point. And notice that on the left-hand side, the derivative of the picture shown, right, the f double prime, which would be the derivative of the f prime, the slope of this is 2 over 1. That's a 2. But unfortunately over here, the slope is down 2 over 2, which is a -1. So f double prime does not exist since the limit of, as x approaches 3 from the left of f double prime is going to be, of f double prime of x, would be the slope over here, which is 2, and the limit as x approaches 3 from the right of f double prime of x, the derivative on this side would actually be a -1. So that's a full justification for why the f double prime of 3 would not exist, and the f double prime of -5 being -1/2, again, is just because of the slope of the actual line.